Hello, welcome to Math 251, Calculus 1 here at Cañada College. My name is Lapuz and I'm the instructor for the course. In this video, we will take a dive into section 3.8, implicit differentiation. What is implicit differentiation? Well, the objectives that we want for this course is to try to find the derivative of some implicit function or some implicit relationship between x's and y's, and try to find a derivative of that with respect to one of the variables, usually x. And then we're going to use implicit differentiation to find the equation of a tangent line. So implicit differentiation, this is an example of an implicit function. You got x squared plus y squared is equal to 25. It is implicit because there's a relationship between x and y, but as a function, you don't have y by itself. So one way to make this into a function is to solve for y. And the unfortunate thing is that if you try to solve for y, it has to pass the vertical line test because it has to be a function. And so you're going to lose a piece or pieces of the circle. So this is one way to make a function, to make an explicit function out of this implicit relationship between x and y. You can take you can solve for y by taking the square root of both sides and looking at the positive part, or you can take the square root of both sides and look at the negative part. You can't look at both parts at the same time because you would get that circle and you wouldn't pass the vertical line test. And then this other strange relationship is that you can find the function y as a function of x by just taking half positive and half negative, and then there's another half positive, half negative combo that you can do. But in any case, what we want to do is we want to avoid having to explicitly solve for y as a function of x just to be able to take the derivative. And the idea is that by using implicit differentiation, we can keep the integrity of your function as a y that has a relationship with x, and then just find a piece of that function that would be important for us without having to solve for y. We can still find a derivative. So here's a strategy. The idea here is to you take your equation, whatever your equation might be, with both x's and y's, possibly on both sides, and then take the derivative implicitly. So that is, for example here, where you have a sine x, the derivative of sine x with respect to x is just going to be cosine x. However, if you have a y inside of that function, like a sine y, and you want to take the derivative with respect to x, then the derivative of that is going to be cosine of y times, the chain rule tells us times, we have to take the derivative of what's inside, which is dy dx. So the derivative of sine y with respect to x is going to be cosine y times dy dx. So that's the idea with a chain rule. You have your equation that has x's and y's, you take the derivative, and then anytime you have a y, you follow it up with a chain rule by saying you need to take the derivative of y with respect to x. And so now what we want to do is we want to find all those dy dx's because that's what we want to solve for. We're going to collect that all on one side, say put it on the left side, and then all the other terms that don't have dy dx you can put on the right side. And then on the left side you factor out the dy dx's, and then you divide out by what you've factored out, and so you have dy dx by itself. So that's a general problem solving strategy for finding dy dx using implicit differentiation. And so this will allow you to find the slope, or let's start with the derivative. This will allow you to find a derivative, which is then the slope of a line tangent to a curve at a particular point. Now usually we only have f of x or f prime of x, and then we just need the x value to find our equation, and we found our y value by putting that x value into the equation. But in the cases where you're looking for a tangent line of an implicitly defined function, like in this example we have the Folium of Descartes, they would need to give you, or you would have to find not just the x value of the point, but both the x and the y value of the point. That has to be given to you And so given your x and y value of the point, you yourself can find the slope by finding the derivative implicitly, and then you put in the x and y values into that equation or that formula that you just found for the derivative, and then you would get your slope, and then now you have a point and a slope to find your equation of the tangent line. All right, so that is the quick overview of section 3.8. Good luck.